second part for this chapter 27, we're going to look at telomeres as well as centromeres. So this is extremely important. You'll see that at the end of every chromosome and both ends, you have areas of DNA that we call telomeres. Those are non-coding series of repeating sequence of nucleotide, TTAGGG, n times, meaning that those guys are not coding for any protein. Why is that important? Well, they are end caps or covers. What they do is to protect the end of the chromosome from any change that may alter the more important coding sequence that exists in the DNA. Now, this helps, so every time you have a cell that divides, well, a section of it is going to be lost. So those DNA ends are going to prevent DNA ends from fusing to the DNA in other chromosome or DNA fragments. So this is a review of the structure of chromosome. Excuse me. You have here a replicated chromosome. So you have the two sister chromatids that are attached in the middle by what we call the centromere. And on each side in purple is what we call the telomeres. So every time a cell is going to divide, well, it's going to start with a very long stretch of telomeric DNA, those telomeres. Every time a cell divides, portion of that repeating sequence is lost. So as the cell ages, the telomere gets shorter and shorter. Now, when you get to a very short telomere, that's what we call here senescence. If you keep going shortening beyond this stage, well, this is going to be where you have instability of the DNA and most likely a cell death. The enzyme that adds telomere to the DNA is called telomerase. Now, this enzyme is only active during embryonic development, and in adults, telomerase is only active in germ cells, the one that lead to having sperm or eggs. Very important is also to notice that telomerase stay active for cancer cells, which are evil cells. No speculation on this. Well, shortening plays a role in aging. So at some point what we find, and you'll see the last slide that I'm showing you, is if a cell keeps dividing as you age, eventually you're going to chunk off all the telomeres, and that's going to start chunking off coding region of the DNA. So some of the example they had and some instrument they use in laboratories such as mice, where they can tell those mice age prematurely, and if they become pregnant, their embryo do not survive. As I said earlier, cancer cells are known to contain active telomerase, that enzyme which is able to keep immortality for those tumor cells. I told you the oldest living tumor was from a lady who had breast cancer who passed away. This breast cancer was revealed in 1959, and as of today, the tumor of that lady still keeps growing and not dying in laboratory experiments. So that's pretty much where the research is, and I really like this slide. I added this from just a website. Just showing you here, you have replicated chromosome attached by a centromere. You see at the end the end cap, those are the telomeres, end cap that protect the chromosome. And you see on the right side the cell divides into two cells, then each of those divides again into two cells, and then two. So as you're aging and over time, those telomeres shorten, and eventually they will start going to not having any more telomeres, and that will really stop the cell division.